All right, so if you watched my last video, then you should recognize this. This is the drone slinger. It's a handheld device that I created specifically so that you could launch fixed-wing drones without having to throw them. Basically, this uses elastic bands, and you would manually pull this back and then pull the trigger, and it would fire a drone into the air. Now, when I created this device, it was very much designed for one very specific aircraft. That was my Wing H1. And that did work, pretty good. Now, as you see in my last video, I managed to use this device to launch the Wing H1 into the air multiple times with no problems. However, as I already was aware, but as a lot of people pointed out, that was kind of, it was a fun gimmick, but it was entirely pointless. The Wing H1 is a very easy aircraft, just launch. It didn't need this to launch it. And a lot of people said that actually what would be a lot more useful is if we had, a device that was like this, but it was actually designed so that you could fire a flying wing type drone into the air, because flying wings are inherently quite difficult. That's not to say that all flying wings are difficult, but some of them can be difficult. They can experience torque while on launch, and sometimes like your fingers get caught in the props and stuff. So yeah, people sort of suggested that if something like this could be made but designed to launch a flying wing style drone, that would be a lot more useful. So that's what I've been working on for the last couple of months, and I will show you the Drone Slinger version 2 right now. So here it is. This is the Drone Slinger version 2, and this thing is designed very specifically to launch flying wing drones into the air. This has taken a lot of work to design this. I had to go through a lot of prototypes, a lot of design changes, many hours spent just sat there just thinking like, how do I do this? A lot of time researching, a lot of time talking to ChatGPT. But eventually I managed to create this device, and without praising myself too much, it actually works extremely well. Now, obviously I will show you me using this in a bit, but I think the first thing I want to do is I want to just give you a little bit of a tour of this, because actually quite a lot of design and sort of engineering went into this. I'm quite proud of it, but also I just want to kind of explain to you how this works. So that's what we're going to do now. I'm going to give you a little bit of a tour of this device, and then I will show you me actually using it. Let's go. All right, so here is the Drone Slinger V2 up close. And probably the first thing you notice is that there's actually a wire sticking out the back. And that is because this device is actually electrically powered, or at least kind of electrically powered. So just like the Drone Slinger V1, the propulsive force that actually launches the drones into the air is just some elastic bands. These are big, thick, kind of industrial elastic bands, but they are just elastic bands. And on the Drone Slinger V1, because the drone that I was launching, the Wing H1, because that was a very light aircraft, I think it came in around sort of 280 grams, I only needed to use 4 of these elastic bands. And when fully stretched, like to fully pull them back, that worked out around sort of like 11 kilos of force. That wasn't too hard to sort of like manually stretch back with your hand. So the Drone Slinger V1 was entirely manual. However, because this Drone Slinger V2 is going to be designed to launch much bigger, much heavier aircraft, I've ended up using significantly more of these elastic bands. I've gone from 4 up to 12. And the force required to pull all of these back all the way up to here works out to be around 30 kilos. Now that is very, very difficult to do. It's not impossible, but it is very, very difficult to manually pull these all the way back to here. So that is why I've got a load of electronics here. What we've basically got is a winch system, a computer controlled winch system, which will, when you press a button, this will pull these elastic bands all the way to the back and basically load the aircraft for you, ready to fire, without you having to kind of ruin your muscles trying to do it in the process. So just to look at this a little bit closer, so what we've basically got here is a 12 volt DC electric motor. This is, the brand is called Gritisan, I think that's how you pronounce it. And this is a 100 RPM motor that's rated for 4.5 kilos. There's actually 2 parts, because you've got the motor section here, and then it comes with a little gearbox pre-installed, which basically it takes the motor's speed, slows it down, increases the torque. However, as I said, that's 4.5 kilos that this can pull, whereas I need to be able to pull back 30 kilos. So that's why we've then got this 3D printed gearbox. There's 4 gears in this gearbox. There's a small one down there, you can see it in orange, and then there's 3 bigger ones here. I can't remember off the top of my head what the gear reduction is here. I'll put it on the bottom of the screen. But basically, I use ChatGPT to figure this out, and this little gearbox here takes the motor's output. It slows down the motor a lot. That is an annoying aspect of this, but it massively increases the torque, which means that this motor basically then has enough power to be able to tract these bands to their full length all the way up to here, saving me from having to doing it myself. And the interesting thing as well is you don't even need an especially powerful battery to do this. I've just been using this little tiny GMB 1100 milliamp 2S LiPo battery. Very little power in this, and yet this little battery here is able to power this device, power the motor absolutely fine, to the point where I can probably load this device probably like sort of 30-40 times just using this battery alone. So it doesn't take a particularly big battery to do this. But as you'll see in a bit, the trade-off is time. Like, although this does work very well, and this system can sort of self-load, it is a little bit slow. That's kind of the price you have to pay for having massive torque. So yeah, so just to explain kind of what we've got on here. So we've got the motor, and obviously we've got this gearbox with the 4 gears here. This big device that you see here, this is called I think it's a IBT2 or an IDD2. I'll put it on the bottom of the screen. This is basically a motor driver. Now this is a brushed motor, and with a brushed motor you don't need to use an ESC like you would with like a drone motor. However, part of the way that this system works is this motor needs to be able to reverse, and I'll show you why in a bit. But I need to have the ability to move the motor forwards and move the motor backwards, and the way to do that is to use one of these. It's called a motor driver. So that's what this is here. It's just handling the sort of motor ability to go either forwards or backwards. Down here, hopefully you can just about see it. This is where I've got a microcontroller. This is a Arduino Nano. I can't remember exactly which version, but it's an Arduino Nano there. And this is what's going to be basically controlling the motor and controlling the logic. Because there is a sort of computer logic going on in this, which I'll demonstrate to you in a little bit. But basically, to make this sort of system kind of as automatic as possible, there are a series of switches in here. So there's a switch here, there's another switch here, and then there's a big switch at the end there. I'll show you that properly there. Basically, when you press this big switch at the end here, this will start the system, and the winch system will pull these bands all the way to the back. The system will then detect when the bands have been pulled back by this switch being activated, at which point the winch system will then reverse. I'll explain to you why in a moment. It will reverse all the way back to the beginning, and then this switch gets activated, which tells the system to stop. Basically, it's a little bit complicated, but that's why we've got the microcontroller there, so that it can kind of automate the whole process for you. So anyway, that's the sort of the complicated end. Let's now look at the rest. So the first thing I obviously need to mention is this is, like the Drone Slinger V1, this is entirely 3D printed, and this is all being printed in PLA, nothing special. Would probably be a lot better to print this in something else, like PETG or nylon or something. But it does work in PLA, at least sort of initially. In terms of longevity, you'd probably want to print in something else, because PLA does eventually go brittle with time. Now, as you can see, this is all being printed in modules, which are all bolted together. Now, the reason for printing this in modules, quite simply, is because I've got a fairly standard size 3D printer, but I don't have an enormous one, so there's no way to print this all in one go, so you do have to print it in modules. Each of the modules has been printed at 20% infill with 4 walls. By default, it uses 2 walls, but I set it to 4, and that seems to make all of these parts perfectly strong. Now, I just wanted to show you this bit here, just because, well, you'll see why in a moment. This bit here, this is a folding kickstand, so you can pull it out like that, and it will lock into place. And you'll understand why that's there in a moment, but it just makes using the device a little bit easier. So what we've got, basically, is we've got this part here. This is a little shuttle component, or a little carriage, and this is able to slide down these rails here. Hopefully if I look at it kind of end on, you can kind of see the rails, the sort of indented. That is what this little device here slides down. And when this device is fully loaded, this bit here, these bands and this bit of rope here will be wrapped around that. So when you pull the trigger, this little shuttle will then be fired down these rails at a hell of a speed, and then it will fly off the end. Now, this is where things get a little bit complicated to explain. But if you think about it, the shuttle here needs to be able to, just fly straight off of the end of the device like this. That's absolutely fine. However, the device also needs to somehow engage with the winch system. Obviously, we've got the winch system here, and this is the rope, which is obviously part of the winch system. When the winch is retracting, this little metal washer here engages with the front of the shuttle, and then obviously then kind of pulls it backwards like that. The problem is that if that was just kind of like lifted up like that, so that I can engage with that, it would mean that when you then fired the shuttle wouldn't be able to slide all the way down to the end, because it would eventually end up hitting this piece here, and you'd end up breaking something. So what I had to do is I had to engineer a system where the winch was able to lift up when the device was being loaded so that it could engage with the shuttle, but then the winch needed to then drop down so it could then be out of the way. And the way I've done that is I've used this half moon pulley wheel down here. So hopefully you can kind of sort of see this at the moment. In the default position, the pulley wheel is sort of downwards, and that's pulled the winch downwards, which means that the shuttle is then able to slide over the top of it and clear it and fly off the end without any problems. But when the winch system is then engaged and the rope is pulled tight, as you can see here, it lifts the pulley wheel upwards, which in turn lifts up the little washer here, that lifts that upwards, so that it's then able to engage with the shuttle. Hopefully this will make more sense in a bit when I kind of demo how this works to you. But that ended up being a really tricky problem to solve, trying to figure out how to come up with this winch system that could lift up and drop down. I tried loads of complicated methods, but in the end this half moon pulley system worked really well. Now, just to explain, so the winch here, this is a Kevlar rope. I can't remember the brand, I put it on the screen. It's rated for 45 kilos of force, which obviously I need because this is pulling a lot of force. But then after you get to the end of it here, where you've got the nut and the washer, the parts that engage with the shuttle. But then on the other side, we've then got elastic. And this elastic, it goes down underneath the device, around the pulley wheel. It then goes, hope you can see it there, it then goes into this section here. The main point of this section here is just for a little bit of structural reinforcement, but it also does house the elastic, and the elastic goes all the way down to this bit here, and this is just like a little tensioner knob, because as you'll see in a bit, like having the elastic at just the right tension is very important. So you can rotate this knob just to adjust the tension, just to get it exactly right. So yeah, hopefully you kind of understand how this works. Like I said, I will demo it to you in a moment. Now, the other things I need to explain to you. So along the top here, hope you can see, I've got these little silver bits here. These are bearings. There's 1, 2, 3, 4, 5, 6, 7, 8. So there's 16, 8 on each side. The reason why these bearings are here is because when you've got the drone installed, the back of the drone engages with this, but then the wings of the drone, they rest on the sort of the edge of the device. Obviously, to reduce friction as much as possible, that's why I've installed bearings here. So the drone will rest on these bearings, and then when the drone is fired and it's accelerated down here, it rolls along these bearings. Basically means I sort of get minimal friction, kind of maximizes the efficiency, hopefully to just get more power into the device. So yeah, the only other things I really need to explain is the trigger mechanism. I'll have to put a little graphic on the screen to kind of explain this, but basically, yeah, as the shuttle here gets pulled backwards along here, as it gets pulled backwards, it'll engage this little white part here. This is spring loaded. You can see that here. So it'll slide over this bit, push it down, and then when it's moved past it, that bit will ping back up, and that then engages with the shuttle, which means that the shuttle cannot then move forwards. And that will be when the device is loaded. Now, when I then pull the trigger down here, what will happen is as I pull it, it will allow a little arm to drop down, which will then allow this entire thing to drop down. And that's what then releases the shuttle, so it can then fire off down there and launch the drone. Other things to mention, Also, I've got the switches here. These are part of the sort of the logic processing. Obviously, a whole lot of wires down there. I think I've probably covered sort of the majority of this. One thing I do just want to mention, you may notice that at the bottom of the device, all of these modules have got this kind of, it's like grid texture to them. This isn't actually for improving like sort of the strength of the parts or anything. This was an interesting little hack that I discovered. So when I was trying to print these modules, obviously there's pretty high tolerance that I need. I need these parts to sort of engage with each other perfectly, because otherwise this wouldn't be able to slide down here, you know, smoothly. So I needed all these parts to be perfect. And initially I found that when I was printing these parts, they were warping, you know, in the corners here. You know, warping is a very common problem with 3D prints. They're warping, and that meant that they wouldn't engage. Now, long story short, I spent a long time trying to troubleshoot this, and eventually I found some obscure Reddit posts where someone said that if you incorporate like a grid-like texture like this into the bottom of your large 3D prints, that massively mitigates the problem with warping. So I tried it, and yeah, true enough, it works. It's massively, you know, basically solved the problem of warping in the parts. So that's why all these parts have got this little texture on like that. So yeah, and just in case it's not clear, the reason why we've got the kickstand is because obviously as we're loading this device, this pulley wheel needs to be able to like rotate like that. Show you from the side, it needs to be able to rotate like that. Obviously if the device was just resting on the ground like that, this wouldn't be able to rotate. So the kickstand is actually very important. You need that there just so you can lift the front of the device off the ground so that this can lift up. So yeah, I think that basically covers sort of the, you know, the basics of, you know, how this all works. But I think the thing to do now is to actually demonstrate it. Okay, so as you can see, I've now got the battery connected to the device, and you know, the system is powered on. And the first thing I need to do before I do anything else, I do just engage the shuttle with this little bit of rope here. As you can see on the back of the shuttle, there's this like sort of little hook bit. So the rope just kind of engages with that like that. And then once that's done, all I've got to do is press this button on the back of the device here, and that should then start the system going. And there you go, you see the motor start spinning, gears started turning, and it started to pull the winch. We then just move down to this end here. So now you can see that as the winch is being pulled, it is lifting that half moon pulley up. The silver bit you see there is just a little magnet that engages with the nut and the washer there. That just helps the winch to pull the pulley into the position it needs to be. And then once the pulley is pulled upwards, you know, just tension in the rope is able to hold it in place. And as you can see, because the half moon pulley is lifted up, it's lifted the winch a little bit higher, so it's now reached a point where it can then engage, get in focus, reach a point where it can then engage with the shuttle, which means that now as the winch is retracting, it's now pulling the shuttle back as well. Ignore the fact this rope's a bit frayed, I need to trim this down, I haven't got around to doing that yet. Now you may have noticed a slight change in the audio. That's because for this section here I've decided to film with my phone rather than my GoPro. That's just because I find that my phone is better at sort of focusing on things up close. The GoPro is not very good at doing that. Now as you can see, this process is quite slow. You're also going to notice in a moment it does get quite loud. That is because as it's being pulled back, there's a lot of resistance happening. Crucially, there's a lot of resistance happening at this point here. That is because I made a slight error in the design. There is supposed to be a little bearing wheel here, but I messed it up, so the bearing's in the wrong position, so I had to put a little plastic shim in temporarily. That's causing a lot of grinding sounds in the rope, which obviously does sound horrible and scary. But on the final version of this, when there's a bearing in place there, hopefully that sound will go. So now we see here the shuttle is about to engage with the little white part of the trigger mechanism, and you'll see the white part will move downwards out of the way. And then in a moment, what you'll hear is a little click sound, and that will be the trigger mechanism engaging and locking with the shuttle. And then as it did that, hopefully you saw, it activated that switch there, which told the microcontroller to then reverse the system. It then sent a signal to the motor driver to reverse the system, and now you can see that the winch is starting to move backwards out of the way. And what you'll see in a moment is that the half wheel pulley, it's already starting to do it. There you go, it now drops down, out of the way. That's then lowered the angle of the winch. So rather than being upright, it's now going to be downwards. And then what will happen is that this will continue to move all the way down to the end. And then when it reaches the end, the little nut there will engage with the magnet, which will then hold the, the winch down out of the way, ready for firing. Now, as I said, this system is annoyingly, it's quite slow. That's kind of the price that you have to pay. If you want high speed, you normally have low torque. If you want high torque, you normally have low speed. That's just the way that motors work. Obviously, I would like it if this system was, a lot quicker, but as I say, this is the price that you've got to pay. So as you can see, the winch is almost back down at the end, and when it reaches the end, what you'll then see is there's another little switch here that will then get activated, and that will send a signal to the microcontroller telling the system to then stop because the cycle is complete. So we're getting close to the end now, and you'll probably hear a little click just as that engages with the magnet. Move that little bit there. I need to trim that little bit of rope as well. So any second now. There's a little click. The rope will then go a little bit slack, and then in a moment you'll see this switch get activated. It'll get pushed down. The system will briefly rewind for 2 seconds, and then it will stop. There we go. And that is the device now fully loaded. So these bands have been stretched to 40 centimeters. They are absolutely stretched to their max. This little shuttle is now ready, so that when I pull the trigger, these bands are going to accelerate the shuttle down these rails at a hell of a speed. And what I've done is I've just put a little box over there that I'm going to shoot. Let me just get my GoPro and I'll set it up and then we'll fire it. Okay, so just set my GoPro up there by the box. As you can see, there's already a little bit of a hole in the box where I fired it before. But yeah, so all I've got to do now, just got to reach my hand under, pull the trigger, and you'll see this little shuttle is going to get fired at a hell of a speed straight into that box. As you can see, this device has got a hell of a lot of power. Now the final thing I just want to sort of show you and explain to you is the wing that I've been using for testing the device is this one here. This is my Atom RC Fear flying wing. This is I think it's a 600 millimeter wingspan aircraft, and I have not built this to be light. I built this last year, I think it was, or maybe in the year before, so I wasn't conscious of weight in the slightest, but this does weigh 656 grams. And this is the wing that I've been using for the testing. And I just want to show you how exactly it is that the wing installs on the device. So basically you'll see, hopefully, this little notch bit here, that just engages with the nut on the back of the aircraft like that. And then you just need to just kind of obviously try and have the aircraft reasonably straight. And you don't go putting it on like that because that isn't going to work. You just kind of put it on sort of as straight as you can, like that. And that means that then when you pull the trigger, the little shuttle obviously gets accelerated down the rails and it pushes the aircraft from the back. And that's actually kind of important because I found from experimentation, originally I had it set up so that it pushed the aircraft in the middle, but then I got lots of like torque roll and G-force problems and stuff. But by pushing the aircraft from the back, it mitigates all of those problems and allows this to just launch into the air with absolutely no problem. So yeah, that is the aircraft that I've been using. Now in theory, this device could be used with any kind of flying wing that's sort of similar in size and shape. I haven't tested that yet, but I will do. But I can't think of any obvious reason why this wouldn't work with similar sized flying wings. And yeah, the main benefits of this is it means that you can just launch flying wings with no sort of issues with like torque roll. It means that, if you're flying with like your missus or something and she doesn't know how to launch one of these properly, you can just get her to use this. Makes it very easy to launch. And also crucially, it means that you don't have to have your fingers anywhere near the propeller when it's being launched, because, a lot of people accidentally, their fingers go through the propeller. So yeah, I guess the only other thing to explain, just in case it isn't sort of apparent, is that obviously you need to use launch mode with this. So, when the aircraft is installed on the device, you enable launch mode. You very specifically need to enable it so that once launch mode's active, the motor does not spin. I'll show you the settings on the screen so you can see, but the motor needs to not spin. And then it's programmed so that I think it's like 0.1 of a second after the trigger is pulled. That's when the motor will fire up. And then this thing, hopefully at that point, it's left the end of the device and it'll be up in the air. Like I said, I'll put all the settings on the screen so you can copy. So yeah, so now I guess it's the time to sort of show you some footage of me actually using this device and to let you know whether or not it actually works. And well, of course it works. I wouldn't be making a video talking about this if it didn't work. No, it works absolutely fantastic. So I've tested this a couple of times, and obviously I'll put the footage on the screen for you now. And as you can see, it works absolutely beautifully. Now, on this first test that you're seeing here, there's absolutely no wind. So as I launched the device, as you can see here, the aircraft did dip just a little bit as I launched it, but it still went up into the air with absolutely no problem at all. And then on the next day where I was testing it, there's a little bit more of a breeze, not a particularly big breeze, but it did make a difference. And as you can see here, on those occasions, the aircraft just went straight up. It went straight up into the air with absolutely no problem. And, there was absolutely no sign of torque roll whatsoever. And obviously, if you're into sort of like flying wings, you'll know that aircraft like this, they do tend to sort of roll a little bit with torque roll, especially the more powerful ones. So yeah, it's actually really nice to see that, with this device, you don't get any torque roll. And I'm guessing that's because as the aircraft is, accelerating down the device, it's picking up enough speed over its wings. That means that once it gets into the air, there's already enough kind of aerodynamic forces to kind of hold it straight so that when the motor then fires up, it's able to kind of fight the torque roll. I was very nervous when I started this project as to whether or not, I'd have any issues with torque roll, but as you see, it works absolutely perfect. So yeah, and I tested it a couple of other times, and every single launch with this has worked absolutely perfectly. So yeah, I'm actually really happy with how this project's sort of come out. So there you go. There has been a little bit of tour of the Drone Slinger V2 for you. And hopefully, you like it. It's taken a lot of work to, design this and to actually get it working. It's like so much troubleshooting. I nearly gave up many, many times. So no, if you have enjoyed this video, please do give it a like and, just show a bit of support because, like I said, a lot of work went into this. And I just want to sort of say as well, this isn't designed with any aesthetics. At the moment, this is very much, a functional device. If I was to continue with this project, I would try and make it look nicer, a little bit more ergonomic. It doesn't feel particularly nice in the hand or anything at the moment. So I would try and make sort of like a nice looking design. But yeah, it's a very sort of just functional device. And as you saw, it works absolutely perfect. I may try in a future video to try this with another wing. I don't own any other wings myself, but I might see if one of my friends will let me try one of their wings on this device. And it's quite a nice thing actually about the Drone Slinger V2 versus the V1 is on the V1, the way that it was designed, you had to 3D print a little hook that you glued onto the aircraft, which obviously isn't ideal. Whereas at least with this new design, because it works in a different way, you haven't got to modify your aircraft at all to use this. So in theory, yeah, you could use hopefully any sort of similar size wing would fit on here. And I reckon there's the potential to make this even more powerful. Like I said, at the moment, I'm using 12 bands. I reckon I can maybe increase that a little bit more. Maybe sort of go up to like 15 bands or 16 bands or something. I reckon that might be doable. And then in theory, you'd be able to fire, even bigger or even heavier aircraft. But yeah, I think I've done enough talking for this video, but I hope you have enjoyed this video. I hope you've enjoyed this project. I may at some point in the future put the design for this online. We'll see if anyone's sort of interested in it or not. But yeah, as I've already said, if you enjoyed this video, please do give it a like just to show a little bit of support so I don't feel like I've wasted the last couple of months of my life. And yeah, I guess I'll catch you in the next one. Cheers, guys. Bye.